Hi, welcome to this video lecture. In today's lecture I will go through superposition in more depth. So this is sort of a part 2. So if we continue on the idea of beam splitters that I started on in the first video, you will find that I will just draw it out real quick. So this is the beam splitter, the first one, and here's the beam of light. The beam splitter will split the light into two exact beams, and they will get reflected by a mirror each, and then they will be collected into another beam divider or beam splitter here, and then they will be fractioned again and detected by a detection 1 or detection 2. So you can put something in between called a phase shifter right here. I will get into more depth what that means in just a second. So if you want to describe the state of a photon, it is useful to use a wave function as the one I showed you in the previous video. If a photon is in a given state, I can have a number that allows me to find the probability of finding that photon in a given state. So if the photon went through here, I will have a certain probability of finding it at this point and at this point right here. So we will call the upper beam for alpha, and the lower beam beta. So the upper beam is noted as alpha and the lower is beta. So the probability can be written as a column. It makes sense, right? A column vector like this. I went through this in my direct notation video. And this allows us to find something quite interesting, because you know these are probability amplitudes. So to find a probability, you need to take the norm squared of that. So alpha norm squared plus beta right here norm squared needs to be equal to 1 always, or 100%. So all the possibilities needs to be equal to 100%. So if I were to be able to locate the photon in every possible state, all those states combined always need to be 100 or 1. If this was not true, that would be the same as saying, if I have two boxes and I know I put a ball in one of the boxes, but I forgot which one I put the ball, then I have a 100% certainty that the ball is in either of those two boxes that I know that I put them in. If that was not true, it would be like the ball disappeared, and that is not how nature works. So we will represent alpha as a column vector 1, 0, where 1 is the 100% chance of finding the particle, or a 100% chance that the particle went through the upper beam, and beta will in contrast be the opposite, 0, 1 in a column vector. It will have a 0 probability chance of being in the upper beam and a 100 probability chance of being in the lower beam. So by vector rearrangement, you will find that alpha and beta in a column vector like this can be rearranged as alpha 1, 0 plus beta 0, 1. That is correct, I think. So the state of alpha and beta is a superposition of the coefficient of alpha of the state in the upper beam. Thus, the superposition to find the superposition of the coefficients beta in the lower beam is 1, 0. So I mentioned before these things called beam dividers or phase dividers, phase shifters I may call them even. So if you have a photon right here and you put a phase shifter here, you will send through alpha, for example, and on the other side, right hand side, you will now have alpha to the EI delta, where delta is a real number. So by taking the norm of a complex number, you do not change the amount of photons. The photon is the same, but you just change the phase by multiplying it. So if we go into more depth about this, here we have another phase divider or phase shifter. And I shine the upper beam light 1, 0 on here. Some of the light will get reflected and some will transmit. The reflected light will be notated as S, and the transmitted light will naturally be notated as a T. So we have found something quite interesting here, that somehow this beam this phase splitter, this phase changer, took an 1, 0 photon and made it to a ST photon. So the same thing occurs if you shine light in the opposite direction. If you shine, if you shine opposite light, the lower beam light. So if we take another beam, a phase splitter here. I do not know why I keep calling beam splitters, but another phase changer here, and you shine O1 light, beta light, on it. You will find that some will get reflected yet again and some will transmit. And this time the reflected light will be notated as U and the transmitted will be noted as V. So we know for certain that, for example, in this example, that the norm squared of S plus the norm squared of T will always equal to 1. The same thing applies here. The norm squared of U plus the norm squared of V will always equal 1. Because the fractions of a probability need to be 100%. That is a rule that you need to remember. So now you may ask yourself, why do we need 4 numbers? That is because of linearity, of course. So let's take, for example, I ask myself, what happens if I shine alpha beta state light on this phase shifter? Let's try that. So here we have another phase shifter. All these phase shifters are exactly the same. So I shine the alpha beta light here. So here comes some alpha light and here comes some of the beta light. And out, well, what do we get? We don't really know. Let's mark them as question marks. But as I mentioned before, we have this formulation, vector formulation, that alpha beta is the same as saying alpha 1 0 plus beta 0 1 vectors. And this essentially equals ds plus p beta, not p pu dt plus beta v. And that essentially equals a matrix. This is where the fun parts begin. With the matrix S, U, T, V. Let me just see if I make these calculations right. Yeah, I think they check through. Multiplied by another column, alpha, beta, of course. So essentially what we have found is that this thing right here is the beam divider. Not the phase shifter, but the beam divider. The beam divider. So essentially we found a matrix that acts on light, the beam divider. And by applying that matrix on the photon state, you will find some pretty interesting things. Thanks so much for watching. Hope to catch you in a future video. Bye.